Today we're going to be discussing prisms. Just to give you a quick overview of today's video, we are first going to be discussing the classification of prisms, how to find the surface area and volume using the inscribed triangles method, and a problem connecting to the spheres topic. So to first start off, we can define a prism as a polyhedron, meaning that their faces are flat. For example, a cylinder would not be a prism because it has bases, whereas regular faces of a polyhedron consist of polygons. Another classification of a prism is that their ends or bases are parallel, so something such as a cone would also not be a prism since it only has one base. The last classification of a prism is that their side faces form parallelograms, meaning that this rectangular prism, if we were to take the face, it would form a rectangle, which is a parallelogram. So in order to calculate the surface area of a prism, we can use a common equation, which is 2 times the area of the base of the prism, plus the perimeter of the base, times the height or length of the prism. So in our example below with a triangular prism, we are given the dimensions, and now we can use these dimensions to plug into our equation to find the surface area. So first what we want to do is we're going to multiply 2 times the area of the base, 7, the height, times 5, the length of the base, plus the perimeter of 7.43 plus 7.43 plus 5, times the height / length of the prism of 10. And we get a total surface area of 268.68 units squared. Now, in order to calculate the volume of a prism, we can use a simple equation, which is the area of the base times the length. But for more challenging prisms, such as an octagonal prism with 8 different sides, it's harder to find the area of the base. So we use a method called the inscribed isosceles triangles method. So feel free to pause the video at this time to try the problem above of finding the volume of the octangle prism. But let's continue. So first off, what we're going to do is inscribe 8 triangles into the octagon, since there's 8 sides to an octagon. And from there, we can find the central angle to be 45 degrees. And then we can represent each of these triangles as shown to the picture of the right, and solve for the height of each triangle, which will help us calculate the area of each triangle, in turn helping us calculate the area of the entire base. To first do this, we're going to take the tangent of our angle, 22.25 degrees, equals 2 over x, and find the area of each triangle. We will then take the area of each triangle multiplied by 8, since 8 total triangles, and then take the area of this base times 6, which is the height of the prism, to find the total volume. If you do this problem, you'll get your total volume to come out to 469.305 units cubed. So our final problem asks us what the largest cube that can be inscribed in a sphere with a radius of 6 inches is. And so to first start off, we're going to have our Pythagorean theorem, x squared plus y squared equals 12 squared, which is the radius times 2, since C and D touch the sphere exactly. And since we know it's a 45, 90 degree triangle, we can rewrite y squared as the square root of 2 times x squared, which we can then rewrite the Pythagorean equation as the square root of 2 times x squared plus x squared, which equals 3x squared, giving us 3x squared equals 12 squared, giving us x is 4 times the square root of 3, giving us the total volume is 332.55 units cubed. Here's a practice problem of a 9-sided prism, so feel free to try to calculate the volume of it. There is a solution listed on this page.